Hello everybody, I hope you're all well. Thank you for joining my webinar today. So my name's Stephanie Wilson and I'm from Suez, where we specialise in water purification systems for laboratory applications. So welcome to episode 3 of our webinar series, where we are aiming to answer your frequently asked questions around purified water and its applications. So this episode is called Understanding Types of Pure Water, and it will take around 15 minutes with another 5 minutes at the end for any questions. You can submit your questions by the chat function at the bottom of the webinar screen, or you can send me an email and I'll get back to you later. So we are aiming to do a webinar series, so other subsequent episodes will focus on the technologies used in the purification process, how to maintain your water system, and the importance of changing your consumables. So as ever, if you have any burning questions around purified water, please send me an email and we will cover it in one of our webinars for you. Thank you. What is pure water? Pure water is also called purified water, and it's water that has been mechanically filtered or processed to remove impurities. Distilled, deionized and ultra pure water are types of pure water and are common terms used to describe water in different purified states. Deionized water, which is also sometimes called demineralized water, has had almost all of the mineral ions removed, such as cations like sodium and calcium, and anions such as chloride and sulfate. Deionized water is a form of pure water and has a resistivity between 1 and 10 megohms. Distilled water is water that has been boiled into a vapour and condensed back into water, leaving the impurities behind. Distilled water is a form of pure water and usually has a conductivity between 10 and 1 microsiemens. The distilling process is time-consuming and expensive, and at Suez Water Purification Systems, we can help you to calculate the cost of distilling water in comparison to using a water purification system. Ultra pure water is water that has been purified to the highest level of purity, where all impurities and ions have been removed. Ultra pure water is a type of pure water and has the highest resistivity of 18.2 megohms. What is feed water? Feed water, or raw water, is water that comes into the building from outside, where the feed water quality depends on your geographic location. So when it rains, water runs through the land and is subsequently evaporated, forming the water cycle. If you live in an area where the land has a high limestone content, the rainwater dissolves the limestone into calcium and magnesium ions, which flows into the source water. It's this high concentration of ions in the source water that causes hard water, which can be problematic as hardness can stick to pipes and kettles, producing limescale, which is hard to remove. Hard water also causes problems in water systems, which is why these ions have to be removed. Where the land is low in limestone, it tends to be high in organics and therefore contains low concentrations of ions, making the water soft. Organics are long-chain carbon molecules produced from naturally decaying vegetation and fertilisers, which flow into the source water, causing high total organic carbon, which is TOC and is measured in parts per billion or parts per million. Other impurities that can affect the feed water quality can include silica, which is a constituent of sand, or even old pipework, which can leach into the water, such as rust. Feed water also contains different amounts of bacteria. The feed water in industrial processes can also be made from a blend, which can include river water, for example, where river water is usually high in organics, or processed water recovery, where other impurities from the industrial process, such as chemicals, may also have to be removed. So all these points that I have just mentioned are very important when selecting the correct water system for your application, which is something that Suez water purification systems can help you with. What is RO water? RO water is water that has been processed by reverse osmosis technology. Reverse osmosis is a spiral wound membrane made up of different layers that rejects impurities. There's a mesh layer that creates turbulence. There are layers with different sized pores. Some layers have charge repulsion to reject the charged ions. Impurities are washed to the drain, and this is what we call the condensate. The purified water is collected in the water collection layer in the middle, and this is what we call the permeate. Reverse osmosis removes 99% of bacteria from the feed water and 98% of minerals from the feed water. RO water is sometimes also called primary water and usually has a conductivity of around greater than 5 microsiemens, which is the equivalent of 0.2 megohms resistivity. However, this depends on your feed water quality. What is deionized water? Deionized water, which is also sometimes called demineralized water, is water that has had impurities and almost all of the mineral ions removed, which is achieved by ion exchange using mixed bed resins. In a mixed bed resin, there are two types of resin bead. There is a cation resin bead, which is fully saturated with H+ ions, and an anion resin bead, which is fully saturated with OH- ions. When the water washes over the resin beads, ion exchange occurs, and the H+ and the OH- ions are washed to drain as water, and the beads become saturated with the other minerals that are in the water. When the resin beads become fully saturated with the other minerals that are in the water, the resins need to be regenerated or replaced. If you are in a hard water area where there are high amounts of minerals in the feed water, the resin beads will become fully saturated with the minerals in the water more quickly. If you are in a soft water area where there are lower amounts of minerals in the feed water, the resin beads will become fully saturated with the minerals in the water more slowly. Deionized water has a resistivity of greater than 1 megohms and up to 10 megohms. You may have also heard about EDI technology, which is electrodeionization. And this technology also performs deionization and removes the minerals from the water, but instead of using a mixed bed resin that has to be regenerated or replaced, it is in the form of a cell, which continuously regenerates the resin beads. And this is a technology that we will be covering in one of the next webinar episodes for you. What is high purity water? High purity water is water that has been purified to a high grade, which is greater than 10 megohms resistivity and up to 18.2 megohms resistivity. And this is achieved by using different technologies to remove the different impurities. So this slide just shows you the process flow of a typical high purity system. So I'll just mention each one of the components. So the first component is a feed water boost pump, and this is to ensure that the pressure is correct across the whole water system. The pre-treatment cartridge is to remove the organics from the water. The reverse osmosis component removes 99% of bacteria, 98% of minerals. The deionization cartridge removes the majority of the resin of the ions in the water, and then water is stored in the storage tank. There's then a recirculation loop where water is taken from the tank and it is recirculated using the recirculation pump through the deionization cartridge, and it's this recirculation loop which is what we call polishing. So the water is constantly being moved, it's constantly being put through the deionization cartridge, and this keeps the water polished to a high grade. There's a microfilter component, and this is 0.1 microns to remove bacteria and any other particulates. And then a point of use UV LED, which is bactericidal. And then water is dispensed at greater than 10 megohms resistivity. What is ultra pure water? Ultra pure water is water that has had all the impurities and all the ions removed and has a resistivity of 18.2 megohms. This is the highest resistivity that can be achieved. Ultra pure water is also type 1 water, where the ASTM water standard states that water is to be purified to 20 microsiemens using distillation or reverse osmosis, followed by mixed bed deionization, UV, and 0.2 micron filtration. You can see that the EDI technology that I mentioned before is not a requirement for high purity water or ultra pure water. However, it can be used instead of the mixed bed resin deionization technology. So this slide just shows you the process flow of a typical ultra pure water system. So again, I'll just mention the different components. So the first component is the feed water boost pump, and again that is to maintain the correct pressure across the water system. The pre-treatment cartridge is to remove the organics from the water. Reverse osmosis removes 99% of bacteria and 98% of minerals from the feed water. And then we have the primary deionization cartridge, and this is to remove the majority of the minerals from the water. Water is then stored in a storage tank. So we've then got the recirculation loop again. So we've got the recirculation pump, and this recirculates water from the tank through the recirculation loop with some extra components. So we've got a polishing deionization cartridge, and this is to remove the remaining minerals from the water, and this polishes the water to a higher grade. There's an ultrafilter, which is 0.2 microns to remove bacteria and particulates. The UV bulb, which is to reduce TOC, which is total organic carbon. And then there is a point of use UV LED, which is bactericidal. And water is dispensed at 18.2 megohms, which is ultra pure water at type 1. So this slide just shows you which laboratory applications require which type of water. Applications that require type 1 ultra pure water can include tissue and cell culturing, PCR and HPLC. Applications that require deionized water which has a resistivity of greater than 1 megohms, can include general lab techniques such as general chemistry, reagent makeup, or media preparation. Applications that require high purity water can include biochemistry techniques such as a direct feed to clinical analyzers. So on the left-hand side of the table, you can see the different laboratories. In the middle, you can see different applications and different types of water. And then on the right-hand side, you can see some of our products that produce the different water types. So this brings me to the end of episode 3. I hope you've enjoyed the webinar on understanding different types of pure water. Does anyone have any questions? You can submit them in the chat function at the bottom of the webinar screen. Just keep an eye on the time because we only get 20 minutes. Okay, so there's a question here. Why does the quality of RO water depend on the feed water quality? Okay, so reverse osmosis rejects impurities. So it rejects 99% of bacteria, 98% of minerals. So if your starting water, your feed water is high in bacteria or high in minerals, for example, then reverse osmosis technology rejects 99% of the bacteria and 98% of the minerals. So there's another question here. What is the difference between high and ultra pure water? So ultra pure water has a resistivity of 18.2 megohms, and this is the highest resistivity that can be achieved. This is type 1 water. High purity water is very pure, but not as pure as ultra pure water, if that makes sense. So high purity water is between greater than 10 megohms and up to 18.2 megohms. So there's another question here. What is in the pre-treatment cartridge? So pre-treatment is activated carbon, and this is to remove the organics from the feed water. So activated carbon is a form of carbon that has been processed to increase its surface area like a sponge. So it has lots of different pore sizes, and the different sized organics get trapped within these pores. So it's mainly to remove the organics from the water and also chlorine. So in drinking water is usually dosed with chlorine to keep the bacterial count down, so that drinking water is safe to drink. However, chlorine degrades the reverse osmosis membranes. So obviously we have to remove the chlorines as well to protect our water systems. So the pre-treatment cartridge is to remove chlorine and organics. Also in renal dialysis, for example, chloramines are very harmful to dialysis patients. So if there's a water system in a renal dialysis setting, you have to make sure that the chloramines are removed from the water that is used in renal dialysis. Okay, how are resin beads regenerated? So the resin beads are regenerated using large amounts of acids and alkalis. And because the process is quite invasive, it's quite a big industrial process using lots of acids and alkalis. If you've got like a small deionization cartridge, we usually just tend to dispose of these and you just change the small cartridges. If you have a larger water system with a cylinder with large amounts of resins, then you can use the exchange service and you can have your cylinders exchanged and then Suez regenerate the resins for you. Okay, so we're out of time today, I'm afraid. I know there's some questions that I've not managed to get to, but if you want to send me an email, I will send you the answer, hopefully. Anyway, please join us next time for episode 4, which will be covering different technologies used in purification. So this will include pre-treatment, water softening and EDI technology. So thank you very much for your time today. I hope you've enjoyed the webinar, and I hope we've at least learned something new or expanded on your existing knowledge. And please don't forget to register your interest for the next webinar. Thank you very much.